So last time we have seen the different types of experimental designs, and we begin with what experimental design is. And today we will be trying to summarize some of the analysis of variance. Okay, so analysis of variance, or ANOVA, is the fundamental statistical test. Okay, and it is the foundation for many of the others statistical approach that has been developed. So it is basic, and it's important to understand what it is and how it works. And it is developed by Ray Fisher in the 1920s, which was working in close contact with people who are doing agricultural experimental agricultural researches, and they had a need to find a framework or a way in how to analyze data, in how to design an experiment and analyze and interpret the results. So this analysis of variance, it has provided a framework for researchers in how to design, test hypotheses, and analyze the data. So let's see what the analysis of variance actually do. So what the analysis of variance actually do is it tests whether the means of categories or your treatments are different. And it does this by partitioning the total variance in your response. So in your data, for the response that you have measured, there is a total variation within that one. And through analysis of variance, it tries to partition that total variance into different components so that you will be able to test your hypothesis. Okay? So let's see this by an example. Okay? So suppose there is an experiment with simple, completely randomized design. Okay? You don't have to hurry to write this down. Okay? So this is something I'm working on progress. Either I will send you the short version, otherwise I will send this one through email for you. Okay? You don't have to worry. Just follow along, and if you have questions, ask. And don't spend time on writing everything down. Okay? So let's imagine you are doing an experiment, and the design is a simple, completely randomized design. And it has one factor. So based on this experimental design and your treatment, what are the source of variation for this setup? So the source of variations come from your treatment variation. That means one factor. In addition to that one, there is a variation that comes due to the experimental error. So the total variation, when you have a simple experimental design, which is completely randomized design, your source of variation are two. These are the treatment effect and the error. And when you add the two, you get the total variance for your response. So what analysis of variance does is, depending on the definition, is it tries to partition these variations into two components, which are the treatment variation and the error variance, and tries to see if your treatment variance is significant. So when you think of analysis of variance, think of like this. So when you are measuring something, and there is a total variation in it, okay, and that total variation could come from different things. In this example, you have a simple experimental design. So you have effect coming from the treatment and effect coming from a random experimental error. And when you add the two, you have the total variation. And the total variation in this one is explained by the two sources of variations. Let's see another example. Okay, imagine an experiment with simple, completely randomized design. It's still the same, but you have two factors, factor A and factor B. In this case, what will be the source of variation? What are they? You are following me, right? So what will be the total source of variation? Effect due to your first treatment, which is A, and a source due to effect due to treatment B. And there could be interaction between the two. So there is also a source of variation that is reflected on your data that comes from the interaction between the two treatments. And always we have an experimental error. So the total variation in the case of this kind of experimental design with two factors is the summation of these two. And when you are doing analysis of variance, what do? you partition it to this one. So you find out the total, and you partition it into each of these categories. Then you try to see if what you have implemented, your treatment, does have a higher, explains the higher source of variations. So in simple concept, this is what we call analysis of variance. Okay. So generally, the partition of the total variance varies based on the experimental design. Even with a small tweak, with a completely randomized design, when we have one factor and when we have two factors, is a little bit different, right? So you need to understand what your experimental design is and think of what could be the source of variations in your data. Then that sum up into the total variation. So the design explains or gives you information in what kind of variations are there. So we have the treatment, as always. We have interaction between explanatory variables that you have in your data. And you have other factors. For example, if we are doing some experiment with blocking, you are doing it to control some sort of variation, right? So in your data, that's reflected. So it is a source of variation. So if you are doing some blocked experiment, when you are doing thinking of the total variance in your data, and it is blocking, you need to be able to take into account the block. So when you are thinking of the total variation, you have the treatment of whether one or two, I don't know, if there is interaction. But still, if you have some block, you need to consider that one. And depending on the complexity of the experiment, if you have nesting and other things, there could be other source of variation. Okay, and that in general, then we have the unexplained variation, which is error. So always when you are analyzing analysis of variance, ANOVA, we are partitioning what? The total variation in your response variable into different components, and we will be testing the different components in how they contribute. So this is a basic concept, and it is important just to bear it in mind.